Welcome back to another video lesson. Today we're going to deal with lesson 10.2. We're going to be still talking about volume, but we're going to change the kind of three-dimensional shape to triangular prisms today. You can fill out page 97 for me in my table of contents, fill out yours. Volume of a triangular prism, it's a little bit different than what we did in the last video with rectangular prisms. So as the name gives away, the triangular prisms deal with bases that are the same kind of triangle. So let's look at some of these shapes. Fill that in on the front cover. You have some pictures and I have some three-dimensional objects as well today. So remember the rectangular prism first. All of the faces were rectangles. Doesn't matter if it was a square or a rectangle, any which way you held it or placed it on a flat surface, the bottom was going to be a rectangle or a square. Today we're dealing with triangular prisms. So if you notice, these have the shape turned so that the bottom on the flat surface or my hand happens to be the rectangle, and it looks more like a tent or a possible ramp. Here's a smaller one that's pretty similar to this red one. What I wanted to show you as well is below that on your notes, you have the same triangular prisms, but they're actually not with the rectangle face on the bottom. It's actually turned so it's almost on end so that the triangle shape is on the bottom. This is actually how you need to think about triangular prisms if you are associating the base with like the bottom of the shape. Sometimes they're going to be turned sideways, and then sometimes they're going to be almost on its end. So the most important thing that you realize is that what we are dealing with is the triangle on either end of this prism is the same. Yes, the other faces are rectangles, but what makes it a triangular prism is that not all of the faces are rectangles. The triangle is going to be the focus really today, because if we were to find the area of this bottom of the shape, again thinking about that Elsa correlation with her making that snow castle, and if you have the area of that castle being a triangle and then you just bring up the walls on either side, that will be the height. So it's important to realize that even if a triangular prism is sitting on its side, you still have to think about it as the triangles are the bases. So I want to just show you some pictures of the three different types of triangular prisms based on the kind of triangle that is the base. The examples that I gave you here are all having a triangle that is an equilateral triangle. All sides are the same. You notice these pictures, the triangle sides on all sides, this would be the same. Sometimes you'll see that hash mark noting that the side lengths are all the same. Sometimes you won't, but that's one kind of triangular prism that you'll see. Often it's referred to as a tent, and you'll see it on its side. Another kind of triangular prism you'll see, often again on its side tipped over, is an isosceles triangle, meaning that two of the sides are the same, and sometimes you will see it on end, and this is another one where this side and this side is both 6.5. The other type is when all of them are different. In addition, you will often see the right triangle as the triangle base. So you can see this looks more like a cheese wedge or a ramp. Sometimes the right angle, like this one, is on the bottom of the shape, and this one as well. You can see that right angle symbol. That points to the base and the height of the triangle's face. So here's the right angle here, here's the right angle down here, and over here. Notice that there's two of them, so there's really a right angle here as well. This one, they just kind of took the right angle and instead of having it resting on the floor, they kind of turned it. The right angle symbol is right up here. All you really need to realize is that there is a triangle base, and when they are tipped on its side, it will be either facing you on the front or it'll be towards the back. And then the height will be this diagonal. So this is an example of one that's on its end. where the base is covered because it's a solid figure, but it's the same, the top is the same as the bottom. And so this is going to be your right angle. And so this is the triangle that you have to pay attention to and find the area of first. And then you have to figure out what the height of this whole shape is. Just like before with rectangular prisms, the formula for volume is the same. So the volume formula is V equals, and it's going to be huge if you have two different colors, big B times H. Big B is still the area of the base, but what's different today is that the area of the base happens to be a triangle. So you will always have to find the area of the triangle and then find out the height of the entire prism. Now remember, sometimes they're going to be tipped on its side, so it's going to look like how long the shape is, but it's still the area of the triangle. Think of it like turned on its end, and then how high this shape is. So because we're dealing with area of a triangle, there is another way to write and think about this formula. That's why I have big B in black. I want you to put a box around big B, because big B stands for the area of the base. The base is a triangle. So to rewrite this, you could think of it as volume equals, and what is the area formula for a triangle? We're going to have to look at that triangle only and find the base of that triangle and the height of that triangle. So that is big B. Then we're going to have to multiply it by the height of the entire three-dimensional shape. So that's why I have some tips right below this to help you, because there's two H's here. There's a big B and a little b and what begins with B. So let's just go through those tips really quick and then we'll try some examples. So make sure you have two different colors. You can do a pencil and a pen, doesn't matter, but big B should have a box around it. Big B equals area of the base. That's where you plug in the area of the triangle, because that's the base we're finding, the area of. We're just going to deal with the visuals today in this video. Tomorrow you might see some word problems where they just kind of write out what each side and what each part of the three-dimensional shape is. So you might see tomorrow the base height and the base length. That's just talking about the triangle base. And the base height, this height of the base is a triangle, is different than the height of the entire three-dimensional figure. So that's why there's two H's. One height is referring to the height of the base of the shape, and the other is referring to the entire height of the three-dimensional shape. So on the inside of your book, we're going to have some examples. This first one, we're going to have to mark up, just like usual. Then we're going to apply the formulas, pluck and plop, solve with the right units of cubed, because we are dealing with volume. I said triangular prisms are the hardest to look at and label. First thing, you want to look for that right angle symbol. Once you find that right angle symbol, that points to the base and height of the triangle base. Remember, if you have a light colored pencil, this, I'd like you to shade, is the triangle base. So that red, for me, right angle symbol is literally pointing to the height and base of the triangle base. So the triangle base has a base length of 8 and a height of 10. So this line right here and this line right here we need for our big B. We also need the entire height of the whole shape. That's going to be this vertical line, because this is, changing my colors to purple, I want you to highlight this part of the shape. This is the height of the entire triangular prism. So that's why I kind of made it more specific. This is the height of the triangle base. This is the base of the triangle base. But this is the height of the entire shape. That's what we need in our formula as well. So let's write the formula out. So I'm going to use colors to make this easier. I suggest that you do the same. Strongly suggest. So volume equals, I'm going to draw my big B in blue, and then my height is going to be purple. So the area of the base, I shaded in blue. So this big B, I'm going to rewrite, and I'm going to plug in the area formula for a triangle. Triangle area is half the base times the height. Notice I put that in parentheses because that is big B. Then I have to multiply this blue piece with the height. So the area of the base is going to be multiplied by the height. So now we have to plug in our numbers. Volume is going to equal, here's the area of the base, 1/2 times the 8 times the 10. The height of my entire trapezoid goes on the outside. Yes, everything's being multiplied. Then you're just going to pick up your calculator at this point. 1/2 of 8 is 4. 4 times 10 is 40. You could do that part in your head. So this whole big B turns to 40. When you multiply 40 times 13, you end up getting 520. Our unit is meters, so our volume is going to be meters cubed. So again, it's just pluck and plop and multiplying, but it's an extra thinking step going from big B to the area of that triangle base. Let's try another one. So this is one that's turned on its side. And so you see the triangle facing you towards like the front of the shape, and then there's another triangle in the back, and then this ends up being looking like it's the length, but it's really going to be the height. Okay, so I'm going to mark this up. This 10 is the height of the triangular prism. Now I want you to shade this triangle base, and notice the right angle symbol points to the 2 lines you need. And notice it's pointing to this dashed line. Sometimes the height is the actual side of the shape. Other times, though, it's in the middle, just like you saw with triangle areas. So this 8 is actually pointing to that dashed line. So that is our height of the triangle base, and this 7 is the base of our triangle base. Now let's plug in the numbers to our formula. So the volume is going to be big B, which is the area of this blue triangle, times the height, which I did in purple, of the entire triangular prism. Remember, the big B is the area formula for a triangle, half base times height, and then I just drop down my other letters, and I'm ready to pluck and plop. So I'm finding the volume, that's the V. The blue triangle has a base of 7 and a height of 8, and the entire triangular prism is 10. At this point, we can pick up our calculator, plug in 1/2 times 7 times 8 times 10, and get our answer. If you wanted to do a little mental math and do 1/2 of 8 is 4, 4 times 7, 28, you can do this in your head as well, but I highly suggest just picking up that calculator and making sure your math is right, even if you're doing it in your head. So this one ends up being 280. Our unit is yards, and then therefore it's yards cubed because we're dealing with volume. There's one more I want you to give a try right below. Try it on your own, starting with the formulas, changing it to this area of a triangle, and then pluck and plop. Go ahead, try it, and then resume when you're ready to check your answer. So for this one, you should have gotten 49 meters cubed. You should have these two formulas, the pluck and plop, and then the picture labeled as well. One just note about this. This is a triangular prism on its end, so it looks like the triangle is at the top and bottom. The numbers were around the triangle that was on the top. Remember, the top is the same as the bottom. So base, bottom is kind of what I like to associate together, but it doesn't have to actually be the bottom. of the shape. Notice I shaded the dotted line red and I drew arrows to this dotted line. That's the height. And then the base of the triangle was 4. The height of the entire triangular prism was 7. Make sure you have that labeled. It'll help you as we move forward as well. Now we're just going to do a couple of examples with finding a missing dimension. Same pieces, we're just finding the height of the entire shape instead of the volume. So here's the volume, 12 centimeters cubed. The height of the entire shape, we don't know. That's the h. And the triangle looks like it's in the front, but then our numbers are in the back. So notice this is my triangle that has a right angle to it. It's the same right angle in the back. So really, I'm going to be looking at this as the base of the triangle base and this as the height of the triangle base. So it's this line right here, which is the same as this one. Notice they're kind of parallel. So this line and this line are parallel. Same with this one and this one. So always look for that right angle symbol to get your height and base for your triangle. Your volume formula is going to be the same. Still going to use my colors because I think it really helps see what's what. So rewriting this formula, we're going to substitute big B for 1/2 the base times the height, and then multiply it by the height of the entire thing. That's what we're actually trying to solve now. Just a quick note, sometimes you'll actually be given the whole area of the base and you won't have to find it. Forgot to mention that. But if you don't have it given to you, you have to use the area formula for a triangle. So now let's pluck and plop the 12 in our big B. We do know all of these numbers. It's going to be half of the base, which is 0.3 times 1. And then we're going to have something we don't know. We're going to take our calculator. It looks ugly. Half times a decimal times 1 is just 0.3 times 0.5. Or if you plug it into your calculator, you should get the decimal 15/100ths. In order to solve for h, we have to divide by that decimal. This is another reason why I want you to use your calculator. I know we learned how to divide decimals, but the focus is finding volume. So h, once we calculate this out with a calculator, ends up being 80. Now we need to write it with our unit. So the h, the height of the entire shape, is going to be 80 centimeters. Remember, height, just a dimension, just put that unit without any threes or cubes or anything like that. Same idea where the h is the unknown. That is the diagonal line right here. It's, again, a shape that is on its rectangular face, so you have to pay attention to the triangle to get your dimensions for that triangle base. Here's the right angle symbol. It's pointing to this line right here. So that is going to be our base. This other line right here, there's no number near here, but remember, this is the same triangle as this one. These two triangles are exactly the same. So this diagonal to going up to the left is the same as this one, and this is 4. So we are going to need that 4 inches as well. So you do have to use all of the numbers that you're given to try to figure out the height and base of the triangle. So volume equals big B, which is the area of the triangle, times the height. Big B is 1/2 the base times the height times that h that we're trying to find. That equals our volume. Our volume is 54, and now I'm going to plug in my 3 and my 4, because those are the numbers that are associated with that triangle base, and we don't know the h. Now I'm going to mentally, 3 times 4 is 12, half of 12 is 6, so this boils down to 6. We're trying to find our h, and we know that the whole thing equals 54. How do you get rid of this? You have to divide by that coefficient of 6 on each side. That goes away, so you're left with h. When you divide this, it becomes 9, making the height of our entire three-dimensional triangular prism 9 inches. forward to working with you more with this. We'll tackle some word problems as well. So enjoy the rest of your day, and I'll see you tomorrow. Bye.